let's do it. 3, 3. And then we're going to take tomorrow, I have a review worksheet that we're going to work on in class. And then we have a quiz on Monday. I know that's a little strange, but it's our only Monday quiz. But that means you have all of Sunday to go to church and, and then study. All right, log functions and their graphs. Log functions. Okay, let's first talk about what a log is. Okay, so we're going to do that looking at its graph. So let's say that we have, let's write down inverse of expo. So exponentials and logs go really well together because when you graph an exponential function and then you graph the log function, all it is they're just inverses of one another. So let's go ahead and start by graphing our basic parent exponential function. Okay, so let's graph y equals b to the x. So y equals b to the x. The point that I like to start with is 0, 1, right here. And then I go right along. Let's just do a growth, and it shoots up pretty quickly. Okay? A little wobbly today. There it is. All right, so let's go ahead and remember some things about this. First of all, we have an asymptote here. Okay? So let's write some stuff in for this one. So we have an asymptote at y equals 0. What's the domain of this function? All reals, good. And then the range is y is greater than 0. Okay, so this is all stuff that you should know. Okay, that's your parent function. We shifted it, reflected it, did all kinds of things. Now we're going to do the log graph. Okay, so a log graph is going to be the inverse of an exponential graph. And so if you remember, the inverse is always a reflection over the diagonal y equals x. So instead of this point being 1, 0, 1, it's now going to be 1, 0. Okay? Instead of having a asymptote at y equals 0, our asymptote is now going to be x equals 0. Everything's getting switched. And so our log graph, our basic parent function log graph, looks like that. All right? So it's an inverse of an exponential function. So our basic log graph is y equals log of x. Y equals log of x. The asymptote, everything gets switched here. So instead of y equals 0, it's now x equals 0. Domain and range also get switched. Okay? So the domain was all real numbers for exponential. That moves over to the range is now all real numbers. And the range was y is greater than 0, so now the domain is x is greater than 0. Okay? So the domain's restricted here. You can't take the log of anything you want. You can't take the log of negative 10. You can't take the log of 0. But you can take the log of positive numbers. Okay? All right, that's good. Now, notice a couple of things on this. Both graphs are 1 to 1, which means they both pass the vertical and horizontal line test. They're both functions. The inverse and the original graph are both functions. If x is greater than 0 and b is greater than 0 but not 1, okay, then we get this. Y equals log base b of x if and only if. I always abbreviate that with 2 F's, if and only if. Now, if and only if statements go both ways. They go that way and they go back this way. Okay, an if statement only goes one direction, but this one goes both ways. So, all right, if we have y equals log base b of x, if and only if b to the y equals x. So here's the log form written in its exponential form. Okay? And here's what you need to know. See, the first year I started teaching logs, I was like, what is a log? I don't even know. I didn't know when I was in high school. I just did them. I was like, what else, you know? And I asked my dad, Dad, what's a log? And he said, a log's just an exponent. Okay? So a log is an exponent. So look right here. See how the log equals y? What's y? Y is the exponent. There you go. So when we evaluate logs, we're trying to find the exponent. Okay? So we're going to do some graphing at the end. Right now I want to do some evaluating logs. Okay? And these get a little tricky sometimes. So here we go, number 1. And these are all done by hand because I know that your calculator can do them. That's good for your calculator. I want to see if you can do them. Evaluate logs by hand. We're going to do our properties of logs on Tuesday. If you remember them, you can use them. But right now, all of these can be solved without using properties of logs. Let's start you off with a little warm-up, something to make you feel good, like you know how to do this. Here we go. Let's try and take the log base 2 of 8. It's an 8. Log base 2 of 8. So when you're evaluating a log, you're trying to find the exponent. What you're doing in your head is you're thinking this. You're like, 2 to the what equals 8. Are you doing that in your head? You should be, yeah. Because what is a log? I don't know. I don't know how to evaluate this, but I do know how to think in terms of exponents. 2 to what exponent gives me 8? And the answer is 3. Perfect. Some of you are going to be pretty fast at these, huh? Yeah. Be careful, though. Careful. Some of them are tricky. How about this one? Log base 3 of rad 3. Ooh. Was that you, Lucas? It was. Did you get it too, Shane? Yeah, 1/2. Okay, so we're thinking 3 to the what equals the square root of 3. Now think of things in terms of exponents. What is the square root of 3? It's 3 to the 1/2, right? So that would be, the exponent would be 1/2. All right, let's do some harder ones. How about log base 5 of 1 over 25? You're good at these. All right, so we're thinking 5 to the what gives me 1 over 25. Well, I know that 5 squared is 25, but how do I get it to be a fraction? Do you remember? Negative. You make it negative, it'll move it down into the bottom of your fraction, and so the answer would be -2. All right, let's do this one. This one's a little scary when you first see it, but then if you just kind of like remember your correct order of operations, it's not so bad. Log base 9 of the log base 2 of 8. All right, so that looks a little strange. We're trying to take the log of a log, but just do correct order of operations, right? Work from the inside out. And so this in here, you want to evaluate first. So that would be 3, right? Log base 2 of 8 is 3. We already figured that out. And then 9 to the what is 3? 1/2. Square root of 9. Good. Aren't these fun? I was looking forward to this like all day. All right. It's a very short day so far. How about log base 5 of 1 over 5 to the 2/3? Yeah, these are not your algebra 2 problems anymore. Okay, algebra 2, we did nice little logs, like log base 10 of 100, you know, stuff like that. Here we're doing a little trickier. Anyone know what the answer is? -2 over 3. Okay, how do we get that? We go 5 to the what gives me 1 over 5 to the 2/3. Okay, so what's going to make this 5 go down to 2/3? How about a -2 over 3? Perfect. I know. No, they're kind of tricky. All right, let's do this one. Log base 2 of 4 times 8. Now don't try and split things up. Remember your correct order of operations. Do PEMDAS first. Do parentheses. Simplify anything you can first. What is 4 times 8? 32. And 2 to the what is 32? 5. Yes, we're good? Okay, here are some basic log properties that you can remember. If you take the log of any base of 1, you will always get 0. Log of 1 is always 0. Because think about it. B to the what equals 1. Any base to the 0 will equal 1. Okay? Also, if you take the log of base B of B, you're always going to get 1. Because B to the what equals B. Another one would be, here's a good one to remember. log base b of b to the y equals y. Okay, someone in my yesterday's class, we talked about this. Someone said, wouldn't it just be 1 to the y? And I said, no, that's different. If you had log base b of b, all of that was to the y, yeah, that would be 1 to the y. Do you see the difference between the two? This one is, do you remember that property that we're going to do on Tuesday that says you bring that y to the front and multiply? Yeah, do you remember that? When you bring y down, you get y times log base b of b, which is just y times 1. Yeah, that's my favorite property, by the way. Okay, and then one more, which is this one's a little weird. But if you have b to the log base b of y, that's going to equal y. Yeah, so if you have something like 5 to the log base 5 of x, that will equal x. One way to think of it is you could take the log of both sides. Like, let's say I take the log base 5 of both sides. Bless you. To log 5 of x equals log base 5 of x. And then I bring this down to the front. So I get log base 5 of x times 1 equals log base 5 of x. So this had to be x on that side. Yeah. That one's a little tricky. There's another way to do it too. I think someone last year came up with a way to prove that. All right, we also are going to have, wait, was that A? That was all on A. Okay. Part B. We also are going to have special logs, okay? So our special logs are common log and natural log. Okay. So common log is going to be logs that have base 10. Base 10, okay? And we never write them as base 10, okay? We just write the log and we just automatically know that that's base 10. Natural logs have base what? Do you remember? E. And they're written as ln, like ln of x. So base 10 would look like this, just log x, that's base 10, and base e looks like that natural log, ln. All right, so let's do some of those too. Number 2, we're only on question 2. Evaluate. So let's evaluate some common and natural logs by hand. You can also do these on your calculator too. I'll show you that in just a minute. Let's do log of 100. Something easy. Something algebra 2e. Okay. So we're going 10 is the base. To what exponent gives me 100? So 10 squared gives me 100. The answer is 2. Okay? Your calculator can do that too. If you have an older calculator, it can take the log of base 10 and base e. So if I did log of 100 on my calculator, hit enter, it'll tell me it's 2. If you have a newer calculator, what you can do is you can go alpha window. Alpha window is a really nice shortcut to a couple of things. They have the absolute value, sigma notation, derivatives, integrals, and then log base. So if you hit log base, you can find log of anything. So if I wanted to find log base 2 of 8, it's 3. There it is. But you don't get to use those very often, do you? I think it's also under math, too. Is it under math? Log base? Yeah, there it is. It's at the bottom. Okay. Let's do another one. Letter B. How about this one? Ooh. 10 to the log 6. 10 to the log 6. This one you kind of got to know that property that I just went over with you. Yeah. The answer is just simply 6. I know that feels really weird. Yeah. But let's see it on our calculator. 10 to the log 6. 6. Your calculator knows this right too. So, let's do some e's now. Let's do the natural log of the square root of e. Okay, you have to think of natural log has a base of e. So we're thinking e to the what equals the square root of e, which is e to the 1/2. So what would my answer be? 1/2. Because remember, Stuff equals stuff. This stuff right here has to equal that stuff right there. It's a really good mathematical term. How about 5 times the natural log of e to the third? Ooh, that's tricky. Yeah, remember Lenny? Lenny, he's always one. He's just a baby. For this one, what I would do is I would use that property that we don't know about yet. I would bring that 3 down. I know, it's funny how they do these and they don't teach you their property yet, but I'd bring that 3 to the front and go 3 times 5 times 1 is 15. Yeah. Ooh, what if I had changed this to 5 times the natural log of e cubed? What's that answer? Are those the same? No, yeah. This would be 5 times 1 to the third power, which would be 5. So those are different from one another, okay? The natural log of e cubed is different than the natural log of e and then cubed. Okay, have you had enough? I've had enough. Let's do the last part. We'll look at some graphs now. It's not, huh? Did I skip something? No, you're just fast. You guys are just good. Yeah, I've done it all. Everything on my paper. Okay. Yeah, it's only been 16 minutes. Dang. Okay, here we go. We're going to graph. Graphs kind of take a little time. I've got like 3 of them for you. So here we go. Let's graph f of x is equal to the natural log of x plus 2. We're going to graph this by hand, and then we're going to answer some questions about it. Okay? So we're going to graph. We're going to also find any y-intercepts, any x-intercepts. We're going to find the domain and the range, and any asymptotes. Okay? So you're going to have a couple of these on your quiz. The quiz is 2 parts. It's a long quiz, too. I was looking at it. On Monday, when we get back, we're going to just, like, go over questions super fast, like literally 5 minutes tops, maybe. So if you have a lot, you might want to come in before school and ask me. But we need to take this quiz. The quiz it's 2 pages. It's a non-calculator calculator. Okay. All right, so here we go. We're starting with your basic natural log graph. And you're like, what is a natural log graph? A natural log graph just looks like a basic, log graph, okay? It just has a base of e, but they all look the same. Here's your parent function. There it is. Start with that, okay? Start with that parent function. It doesn't matter if the base is e or if it's 10. It just kind of makes it a little bit flatter, a little bit steeper. It really doesn't matter. The shape is just the same, okay? So I'm not too worried about that. What we're going to do is we're going to take this thing and we're going to shift it 2 to the left, okay? Because inside. So let's go, and we're going to take this point right here, and I'm going to shift it 2 to the left. And so I get this graph here. And what else gets shifted with it? The asymptote, yes. The asymptote, which starts at x equals 0, is now over here at x equals -2. That got shifted also. Okay, so let's go ahead and answer these questions. Now, the y-intercept, we're not going to get an exact answer if we don't have our calculator for this. The y-intercept, which is right here, is when x equals 0. So that would be the natural log of 2. Okay, just leave it, natural log of 2. It's when x equals 0. The x-intercept, you can see. If you graph it correctly, it's pretty easy to see. The x-intercept is -1. X-intercept is right here, -1. Okay. Domain of this thing, x is, sorry, I almost said y. X is greater than -2. A couple ways to do that. One, look at your graph. See this asymptote at -2? Nothing past it, nothing on it. Okay. The other way is you can look at this and go x plus 2 is inside of this log here. It has to be greater than 0. Oh, I didn't do any of those either. If I ask you, like, what's the log of -10, the answer is no solution. Okay. You can't take the log of negatives or 0. So then you would subtract, and you get x has to be greater than -2. So you could do it either algebraically or look at the graph that you graphed and do it that way. The range is easy. The range is going to be all real numbers. And then your asymptote we talked about was x equals -2. Make sure you write x equals for vertical asymptotes, y equals for horizontal. Okay, let's do another one. What number am I on? 3? 4? Number 3. Number 3, part B. Let's do this one. F of x is equal to 1 plus log x. Okay, that might bother you. It kind of bothers me that they do it that way sometimes. But it's the same thing as rewriting it as the log of x and then up 1. Okay, it's the same thing. It's commutative. You can change it around if that's what you prefer to look at it like that. Now, the thing about moving logs up and down is their asymptote doesn't change. Okay, left and right, the asymptote moves, but up and down, the asymptote doesn't change at all. So this is just going to be your basic log graph, which is at 1, 0. Now it's going to be shifted up to 1, 1, like that. Okay, and then you just draw it in. Looks something like that. And it has an asymptote right here. Okay, and so if we ask for the x-intercept, the x-intercept is actually a little hard on this one. I wouldn't ask you for the x-intercept, because if you had to find the x-intercept, you would have to solve this by hand, which we don't know how to do just yet. I mean, you might remember. Some people are like, yeah, I do. -1, 10, it's 1/10, right? Yeah. But some of us don't, and I wouldn't ask you for that yet. We're going to do that next week, okay? All right, y-intercept, though. Y-intercept would be none. Does not cross the y-axis at all. Domain, x is greater than 0. Range, all real numbers. And then the asymptote is at x equals 0. All right, we're going to do one more. One more. What if I ended up doing, let's do g of x equals negative log of x. Negative log of x. Okay, there's a difference between negative log of x and log of negative x. Very big difference. This one right here is a reflection over what? Do you remember? Here, let's talk about this real quick. Let me write this one down too. So this first one is taking the entire log and making it negative. So it's taking all your y values that were positive, making them negative now. So that would be a reflection over the x-axis. This one's taking all of your positive x values and making them now negative, so you're reflecting over the y-axis. Okay? Do you have a better way to remember that? No? Some people are like, if the negative's next to x, it's over the y. If the negative's out front, it's over the x. It's like opposites kind of thing. All right, but let's just graph g of x. Well, we could graph both of them if you really wanted to, but you're probably about done. All right, so let's graph negative log x. Bless you. I like to just draw in my parent function so that I know what I'm reflecting. That's a really ugly parent function. All right, and then I'm going to take that and I'm going to reflect it over the x-axis. And so this point would stay the same, and it would look like that instead. And the asymptote would still be here. It's very basic. Okay. If it was the other one, h of x, that would be over on the other side. All right.